Graphing quadratics with Algebra 2. So when we go to graph these, we're going to use Desmos. So if you don't have that set up, make sure you pause the video so you can set Desmos up. We are going to be using a specific Virginia Desmos that you will be allowed to use on the SOL, and this is the only Desmos you will be allowed to use on the SOL. So make sure we're going to the correct one. I'm probably only going to do the first and second example with you. I will leave the third for you to do on your own, and you can check in with me in class. But the first two are the ones I'm going to do in this video. So let's start with example 1. We're going to go to Desmos and we're going to type in our problem. So once we're at Desmos, again, make sure it says Virginia. Y equals x squared plus 6x plus 5. And then we can click on our points and they'll stay. And we can see the ones we're going to plot. Notice when we connect our points, this is a U-shaped graph. It is not a V. So let's go ahead and graph these. Your line looks better than mine. Make sure it's a nice U with arrows at the end. Now our most important point is our vertex, which is either our lowest point or it's our highest point for this. It's our turning point. And that is located at -3, -4. Our vertex tells us our shifts as well. The first number tells us left and right. The second number tells us up and down. And it's always from the origin. That's our starting point. So this graph moved from the origin. It went left 3, because that's my first number in my vertex. So I can say I went left 3, and then we went down 4. That's my second number in my vertex. Axis of symmetry is something new, and it occurs at x equals whatever the x value of our vertex is. So x equals -3 in this case. And we can see that where x equals -3, if I was to draw this dashed line, our graph is symmetrical on each side. Notice our points are only, so if we look at our x-intercepts, from the axis of symmetry, it's 2 jumps to the right, and the other one is 2 jumps to the left. We can go up to our y-intercept. 1, 2, 3, and then 1, 2, 3, there's another point. So that is our axis of symmetry. Compression or stretch, again, occurs with the number that's in front of x squared. In this case, it's the number 1. So we don't have to worry about a stretch or compression. We're going to say none. Our x-intercepts are where our graph crosses the x-axis. And these are points, so it's always x, y. So we're going to say it occurs at the point -5, 0, and at -1, 0. Our y-intercept is another point at x, y, and that's where it crosses the y-axis, which in this case is 0, 5. X and y intercepts should be a review from Algebra 1. And our domain and range, increasing and decreasing, and in behavior are all review from our first unit. My domain are my x values, so this is going to keep going to the left and keep going to the right. So we can say it's from -infinity to +infinity. range, the lowest this graph goes is to -4, comma, the highest it's going to go because of the arrows is infinity. Now remember, numbers get brackets, infinities get parentheses. Increasing and decreasing. Again, we only care about our x values. And the farthest left we said this is going to go is negative infinity. And the farthest right we said this is going to go, because of our domain, is positive infinity. So if we start on the left side of the graph, we're starting at negative infinity. And if I trace my graph, I'm going down until I get to my vertex point. So I went down, I decreased from negative infinity to my vertex point, which is -3. Again, we only care about x values. So then from my vertex point on the other side, if I trace, I'm going up. So I'm going up from -3 to positive infinity. And finally, we have our end behavior. It's asking, which direction are the arrows pointing? In this case, they are pointing up, so they both get a positive infinity. Make sure you pause the video if it went too fast, and make sure you rewind to where you got lost, and you can come see me after school anytime. Now we're going to move on to example 2. It's written a little bit differently, but we can still use it just the same in Desmos. So let's go to Desmos, and we're going to get rid of the first one. Say y equals -1/2 x plus 5 squared plus 3. So we can see my new U-shaped graph. And again, I see some points to plot. And if I don't want to plot my decimals, that's fine. You can zoom in and try and find some other ones. You can zoom out. All depends on what you want to do. Looks like there's a point here at -3, -1. So whatever you're most comfortable with is fine with me. Let's go back to graph it. Again, hopefully yours looks a little bit better than mine. Now, our vertex, in this case, is at -5, 3. It is our turning point. It's where it changes directions. It's that corner. So our vertex is -5, 3. And remember, our first number tells us left and right. Our second number tells us up and down from the origin. That was our starting point. So we went left 5 and then up 3. Our axis of symmetry is x equals, and it occurs at the first number in our vertex, our x value, which is -5. So again, I could graph that. And you can see on each side of this dotted line, we are symmetric. So this point is 2 jumps from my dotted line, and again, 2 jumps from my dotted line. Here we do have a compression because it is a fraction and it is a compression by 1/2. Remember to ignore the negative with compression and stretch because the negative just tells us if there was a reflection. X-intercepts are where they cross the x-axis, and I'm going to go back to Desmos to get these. So my first one occurs, I'm going to round this to say -7.5, 0, and at -2.6, 0. So -7.5, 0, and -2.6, 0. My y-intercept, again, if I go to Desmos, I'm looking for where it crosses this y-axis. So it's going to be down here somewhere. Let's see. We keep going. All right, we found it right here, which is at 0, -9.5. Again, make sure you pause the video if it's going too fast, and you can rewind it and watch it again. Now this second column, domain range increasing and decreasing, is all review from Unit 1. So my domain, it's going to keep going to the left and keep going to the right. So -infinity to +infinity. Range, we always start lower. So the lowest this goes is -infinity, and the highest it goes is +3. Right here at this line. 3 gets a bracket, infinity gets a parenthesis. Increasing and decreasing, we only care about our x values. So we set all the way to the left, this graph is going to go to -infinity, and all the way to the right, it's going to go +infinity. So starting on the left, if I trace my graph, I'm going up until I get to my vertex point, which is at -5. So I increased from -infinity to -5. So now I'm at -5, and if I keep tracing my graph, I'm going to be going down. So I'm decreasing from -5 to +infinity. And then the last part we need to look at is our end behavior, which is which directions the arrows are pointing. They are both pointing down, so both get -infinity. So there is a third example for you to try, and it's going to be the same process, just typing it into Desmos. You can come see me and I'll let you know if you're right in class, or you can check the website. I should have an answer key up there, or check with one of your friends too. And just make sure to come see me if you have any questions.